In this lesson, we're going to cover the MongoDB document. Before moving forward, let's just quickly recap. Data in MongoDB is stored in a hierarchical structure. You have your database at the top level, then you have one or more collections that are related to the database. Finally, you have your documents, which are kept at the collection level. Each MongoDB deployment can have many databases, collections, and documents. The general term document tends to represent the way that data is encapsulated and encoded. The specific encoding of the container defines the shape of a document. An XML encoded document looks different from a JSON encoded document. If you're familiar with Java or JavaScript, then you're in luck. MongoDB encodes documents returned to your applications using the JSON format, or JavaScript object notation. JSON is not restricted to JavaScript. It is a format of storing data, so any programming language can take advantage of it. The nice thing about JSON is that it is an open standard that is human and machine readable and writable. If you're feeling a little lost, then keep it simple. MongoDB uses documents for storing data. With MongoDB, a document represents a single chunk of data. If you're coming from SQL, a document is like a row in a table. You have your field, and its assigned value. Just like each column in a row has a value. The value can be any number of supported data types such as string, integer, or date. For the programmers among us, a MongoDB document is kind of like a dictionary, map, or associative array, an object that has a number of key value pairs. But you can do so much more with a MongoDB document than just assign values to fields. The value of a given field can actually be another document. You can also have an array of values or an array of documents. These embedded documents allow you to create richer document structure, where related data can be kept within a single document instead of spread out over multiple documents or collections. Since documents support a flexible structure, you can use a single document to represent an entire chunk of data, rather than having to break that data up into multiple collections. This is a core part of MongoDB's power. Instead of having to query multiple collections and perform joins of related data and assembling it all together after the fact, you can keep your data in a single document and pull it all down at once. The exact structure of a document, all the fields, values, and embedded documents, represent the schema of the document. You've probably heard the term schemaless thrown around in relation to MongoDB. Let's just clarify here. MongoDB is schemaless, in that it does not require you to make complicated changes to a collection's metadata to add or remove fields in a document. Furthermore, the data type of any given field can vary, and you do not have to make changes at the cluster level to support this. Compare this to database solutions where adding or removing columns or fields, or changing the data type of that column or field, can be a complicated and potentially destructive process. That said, chances are the documents in a given collection will have a common structure to them. MongoDB provides tools for enforcing schema shape, but otherwise leaves you with the freedom to shape your implicit schema as needed. When it comes to document schema and design, well, that's a little advanced for this course. The subject of data modeling is better covered in our documentation, MongoDB blogs, and a great video lecture from MongoDB World 2017 by one of our curriculum engineers, Danielle Kupal. You can find a link to these resources below. So far we've talked about MongoDB JSON documents and all it can do. There is one limitation here that's very important to keep in mind. The MongoDB JSON document has a 16 megabyte limit, meaning a single MongoDB document cannot hold more than 16 megabytes of data. Now chances are you're not going to run into this very often, but it's important to keep it in mind when deciding what data to store. Now earlier I said that MongoDB returns documents using the JSON formatting at the application layer. At the storage layer, Mongo encodes your documents using BSON, or binary JSON. BSON is binary encoded serialization of JSON-like documents. The MongoDB drivers automatically handle translating BSON to JSON. All you ever need to worry about is the JSON. But knowing that BSON is under the hood is still important. By using BSON as the underlying structure, MongoDB actually supports more data types than simple JSON. In fact, MongoDB JSON is specifically extended to account for the gap between BSON and JSON's data type support. You can read more about this in our documentation. For this course, just remember that MongoDB JSON is extended to include all of the BSON data types. Let's recap. MongoDB stores data as documents. Documents are stored as BSON but translated to JSON by the client drivers. Document fields can be values, an embedded document, or an array of values or documents. Finally, MongoDB documents have a 16 megabyte limit.